Okay, the third different form of the quadratic we're going to look at is what we call fully factorised. Means factorised into what we call factors. It's a skill or process that we can go into again next week. It might be given to you, or you may have done it last year in high school. So what we have here are three different ways of demonstrating the quadratics. Two factors, the one factor squared, or two factors with a dilation factor at the beginning. So when sketching these, again, ask yourself, is there a reflection? What is the general shape? Is it going up? Is it going down? What's the dilation? Is it steeper? Is it flatter? And then you ask yourself, where are the roots? And they're also called zeros, solutions, or the x-intercepts, and the y-intercept if it's easier to work out in your head. A slight detail here about what roots are. The roots are the x-intercepts, and that happens when y is 0. So if y is 0, then basically that factorised form is 0, and that will happen when either one is 0 or the other is 0, or they're both 0. So basically we're going to find out what happens, what value of x would make each of these equal to 0. And you should be able to do that for linear factors fairly quickly in your head. Let's have a look at some examples. Here's x plus 1 times x minus 2. Get the general shape. Positive times a positive is positive. What are the roots? Well, the roots will happen when x plus 1 is 0, which is at minus 1, and when x minus 2 is 0, which is at x equals 2. Find the y-intercept. The y-intercept happens when x is 0, so when x is 0 I'm going to have 1 times minus 2 is minus 2. Remembering that the vertex, the very bottommost bottom point in this quadratic, happens equidistant from the two roots, then the midpoint between 2 and minus 1 is where the vertex will happen. So it'll be slightly off to the right here. So try and indicate that in your sketch. Here's another example. Axes that are labelled, and here's our equation. Two lots of x plus 3 times x plus 1. General shape is positive, roots at minus 3 and minus 1, vertex, intercept, on we go. Here's another one. Axes that are labelled. 2x plus 4 and x minus 1. Looking for a positive shape, dilation factor of 2, roots at minus 2 and 1, mark on the y-intercept. Axes that are labelled. Here's an equation, 2x plus 1 all squared. It's actually got a minus at the front, so it's negative. I'll pause this one and I'll discuss it. Here's x plus 3 all squared. It's one linear factor all squared. It's still a quadratic. We're going to look at it now. We can see that it's got a positive shape. It's going to be going this way. The root is at minus 3 over here. There's only one of them, which means it's going to bounce off the axis and have a quadratic field just here. It's a double root. Here's another example. X times x plus 7. This one often tricks up students. They fail to see that this is indeed a factor as well. We have two factors here, one x and one x plus 7. When we're finding out the roots, we're solving each of these for equal to 0. One of them is 0, the other is minus 7. 0 minus 7, drawing our quadratic. So here is our factorised form. We've got double roots here, and a tricky root where this x is 0. It also gives us the y-intercept. So the process again is to firstly identify your shape, identify your dilation, check then for roots, mark them on the graph, and put in all the intercepts you can that you can calculate easily. Remembering that to find your y-intercept, you imagine that x is 0, cover them up, multiply them out. For the example, this one here, when x is 0, that disappears, leaves us with 4. This disappears, leaves us with minus 1. 4 times minus 1 is minus 4, which is that particular point there. It's really important that you mark on the axes what the intercepts are, especially if you have not drawn it to scale. And if it's just a sketch, your graph won't be to scale. So the markers are what give us the indication of how steep things are.